Okay, these are parent functions that are important for you to know in your math facts. So these are graphs that are very, very common. For instance, the first one, number one, there's 6 of them. The first one, number 1, is called a linear function. A linear function. And we're going to graph this linear function. I'm going to show you how you could create a table very quickly. Here you've got your input of x and your output of f of x. But we want to memorize these graphs so that we don't have to create a table every time. These are going to be very common functions throughout your algebraic career. So x, if I put a negative 10 in, and the reason I say negative 10 is because I have negative 10 all the way to the left and then positive 10 all the way to the right. So if I put a negative 10 in for x, then f of negative 10, when I put a negative 10 in for x, I'm going to get negative 10 out. So negative 10, oops, negative 10. And then when I put a negative 9 in, I'm going to get a negative 9 out. And hopefully you'll get the language. Put a negative 8 in for x. These are your inputs. Y is your outputs. When you put a negative 8 in, you get negative 8 out, negative 7 out, negative 6, negative 6, negative 5, negative 5, negative 4, negative 4, negative 3, negative 3, negative 2, negative 2, negative 1, negative 1. All of these are called, I'm going to erase my graph here. All of these are called lattice points. It's important to know that I could put decimal values in, but I'm not. Lattice points are ordered pairs that have integer coordinates. Makes it easy to graph. Your point lands on the corner of a box. It doesn't mean those are your only points, it just means those are the most easiest to plot. You put a 0 in for x, put a 0 in for x, you're going to get a 0 out. Put a 1 in, you get a 1 out. 2, 2, 3, 3, 4, 4. We're going to continue this, and this has 21 lattice points. So in this, there are 21 lattice points. I need a straight edge whenever I'm graphing parent functions. Whenever I'm graphing and I'm given a grid, I want to fill in as much as I can and enter and exit the grid. So there's arrows at the end of each part of this line. I enter and exit. I used a straight edge to connect the dots because it is a straight line. It is a straight line. Okay. Number 2 is called an absolute value function. Absolute value function. This time when I put a negative 10 in, I get a positive 10 out because the absolute value of negative 10 is positive 10. When I put a negative 9 in for x, I'm going to get positive 9 out. When I put negative 8 in, I get positive 8. Negative 7, positive 7. Negative 6, positive 6. Negative 5, positive 5. Negative 4, positive 4. And so on. Negative 3, positive 3. Negative 2, positive 2. Negative 1, positive 1. 0, 0. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. And this requires a straight edge as well. You've got 2 straight parts, one in quadrant 2, one in quadrant 1. They meet at the origin at a sharp turn, making it appear as if you have a V. The third graph is a quadratic function. Now this time when I put a negative 10 in, negative 10 squared gives me 100, and that I can't plot on this graph because my y value only goes up to 10. So if I try and put negative 9 in, negative 9 squared is positive 81, still too high. So let's go in a little closer. Negative 5 squared would be positive 25, too high still. Negative 4 squared is positive 16. Negative 3 squared gives me a positive 9 out. Negative 3 times negative 3 is positive 9. So I plot negative 3, positive 3. Negative 2 squared is 4. Negative 1 squared is 1, so negative 1, 1. 0 squared is 0, 0, 0. 1, put a 1 in, I get a 1 out. Put a 2 in, I get a 4 out. Put a 3 in, and I get a 9 out. This is not a straight edge. In fact, it should not look like it is a straight edge. It should look like the curve that it is. Okay? And again, what we did was f of x is x squared, so we put a -3 in. -3 squared is 9. We put a -2 in. -2 squared is 4, and so on and so forth, until we filled up everything that we could fill up on the given grid, and then we connected the dots, because these are continuous curves. Okay, the next one is called a square root function. The square root of a negative number is not real, so I can't put in any negative numbers. So the first number from the left, coming in from the left, that I can put in would be a 0. So I put a 0 in, and the square root of 0 is 0. So you put a 0 in, and the square root of 0 becomes 0, so 0 is my output. When I put a 1 in, the square root of 1 gives me a 1. If I put a 2 in, the square root of 2 is not perfect, but it is something I can go to my calculator with, but I don't want to go to my calculator, so I'm going to look for the next input in which I don't have to grab a calculator, and that would be 4. If I put a 4 in, the square root of 4 is 2. If I put a 9 in, the square root of 9 is 3. And that is also a curve. Now, the graph on number 3 has 2, 4, 6, 7 lattice points, but an infinite number of points. An infinite number of points, hence connecting the dots. That curve is made up of an infinite number of points. The same thing with your square root function. However, on this grid, I'm only showing 4 lattice points. So that's what I'll be looking for when I grade your fact quiz, is 4 lattice points for number 4. Number 5 is called a cubic function. If I put a -2 in, -2 times itself 3 times is -8. -1 times itself is 3 times is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So you put a 2 in, you get an 8 out. And this is also a curve. Make sure you're entering and exiting the grid. This has 5 lattice points. 5 lattice points that I'll be looking for when I grade that quiz. Of course, entering and exiting the grid as well, and the smooth curve. Number 6 is called a cube root. A cube root. So this time when you put an 8 in, an 8, a positive 8, the cube root of 8 is 2. We know that from our exponent quiz, because 2 cubed is 8, so the cube root of 8 would be 2. And then the cube root of 1 would be 1, so you put a 1 in for x and you're going to get a 1. Cube root of 0 is 0. And then this part's interesting. The cube root of -1 is allowed. It's -1. And the reason it is -1 is because -1 times itself 3 times gives you -1. So negative numbers raised to a third power are still negative. And then -8, you put a -8 in and you'll get a -2 out. And this graph, although it has an infinite number of points, has 5 lattice points. 5 lattice points. So hopefully, just hearing the language, input, output, what do you put in, what do you get out, hopefully that is helpful for you. I will say this a lot in class. When you put this in, what do you get out? And what I'm looking for is input, comma, output.